So hi there, this is Kelly. This is a little bit of a different video. I want to do several on calculators. Hopefully we can get them all done before the first exam for folks. But for now, we're going to start with the calculator that I grew up with. I've had it since high school. It's the TI-83. Some of you guys are going to have the TI-80 something. Some of you guys have really more advanced calculators than I do, and they do some pretty cool functions. Um, but then some of y'all are using TI-30X, and that doesn't have as many functions. So we'll see what you can take away from this video. Um, but I'm going to cover some things that are really good for just everybody. We'll start off with really some kind of like DC specific problems to show you examples of how to use it. And we'll end with a problem that's going to be a little more related to AC circuits and above. So for right now, I'm just going to turn this guy on off, right? And so what I've got over here are some problems in calculating tolerance for resistors. We've got a 1 ohm resistor, 500 kilo ohm, and 2 mega ohm. And we're going to just assume that they have a gold band on them that would indicate that they've got a tolerance range of 5%. And so how we calculate those is that we generally do the nominal value times 1.05, so 5% over 100% of itself, or it times 0.95, which would be 5% less than 100% of the nominal value. So what I'm going to do is I'm just going to start by saying 1 times, this 1 standing for 1 ohm, times 1.05. And that gives me, of course, 1.05. And we're going to say ohms, right? Always include your value or unit that you're measuring. Now, if I want to repeat this problem real easily, I can hit second. Second is going to become a good friend of yours. And I'm going to hit second, and I'm going to hit, this is the enter button, but above it in yellow, you'll see that it says entry. So anytime you have a button that has a yellow thing above it, you hit second. And if you want to get that yellow option, then that's when you press that button. So I'm going to hit second entry. Well, that just repeated the thing I typed a moment ago. So I made just 2 button presses rather than typing the whole thing out. And what I just did was I can use these arrows to go back and forth in the calculation. And so what I'm going to do is just hit 0 and 9, and I'm overwriting what was written before. So not only can I can recall the last entry, and then I can go back and I can overwrite certain aspects of it. So, and there you go. And what you'll see there is that on the first one, you have this E here at the end. For realizing I forgot to say that my calculator looks cruddy because I dropped it at one point and it messed up the screen, so apologies. But what you see at the end of the results here is an E and a 0. And this is saying that this is still just ohms. But when we multiplied 1 times 0.95, it's giving us E -3. And what that's saying is that this is now 950 milliohms. It's indicating that that is a result of times 10 to the -3. So that's going to be really important for your engineering notation. And I'm realizing that I skipped something that I wanted to show you. So I don't want to do that. I want to go to mode. So I hit mode because what you want to do is you want to put your calculator in engineering notation. It's going to come in normal, right? But for this class, whatever class you're in the engineering technology department, you need to be in engineering notation. And then you are going to come down here and see this string of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is indicating how many decimal places you want your calculator to show you if you're calculating a decimal number. Now, with engineering notation, we often want to go to 3 places because we need to show at least 2 decimal places, and we need to know if we need to round one of that last decimal place up. So you'd want to go to 3. But if you're in AC and above, you want to go to 5 places. So that's just something to know. But don't let that either of those things determine whether or not you correctly present your answers in engineering notation. And then also you want to go down to this third option, and you want to make sure that your calculator is in degrees. And so, anytime I'm on one of these things, so if I hit enter, now it changes that over to radian. I want it to be in degrees. Anyways, I should have started with this, so I apologize, but that's where we're going. So engineering notation, 5 decimal places, unless you're below AC circuits, which maybe then you can just go to 3, and then degree. And so now I'm going to get out of this by hitting second. In above mode, there's the word quit. I'll just hit quit, and I get out of that in that area. So let's do, let's get back to this. So 500 kiloohms. If I hit, now this doesn't really make much sense for me to well, it's fine. So what I just did is I did second entry and I pulled up the last one. It really doesn't matter if you do 1.05 or 0.95 first. It doesn't matter. But what I'm going to do is I'm going to hit the up arrow. So instead of going back, a few things, I can go to the very top of the equation by hitting the up arrow. If I wanted to go to the end of the equation, I can just hit the down arrow. But I want to go to the beginning of the equation, and instead of overwriting that, because if I overwrote this, I would lose my 0.95. So what I'm going to do is I'm going to hit 5, but I'm going to say second, and I'm going to set, instead of del, the thing that's above it is INS, and that stands for insert. I'm going to hit second insert, and then I'm going to hit 0, 0. As long as I'm still using the cursor where I hit insert, I don't have to hit insert again. Now, if I back out of it, it gets out of that function. But now I've put in 500. Well, wait a second. I've forgotten that I need to put in the kiloohms. How do I make this kiloohms? Well, I'm going to hit second, and I'm going to hit insert again because I need to do one more thing. Now, the comma button above that, you've got EE, and that's basically where you can control telling your calculation that you're in kiloohms or you're in megaohms or in milliamps or something, micro. So I'm going to hit second, and I'm going to hit EE. See, even though it's EE, it just shows 1E. And I'm still in the insert mode, so I can say, and this is kilo, so I can say E3. That's all I want, and now I can back out of that. I didn't even have to do that. I could just hit enter from there. All right, well, there we go. So 475 kiloohms. All right, and then again, no, I didn't really want to go that far. I can hit 1.05, and we've got that answer. Okay. So what I'm doing is I'm showing you how to make all of this stuff happen really quickly, as opposed to writing out a whole bunch of stuff all over again, over and over and over. So then let's go to 2 megaohms. What I'm going to do is just pull that back up. I'm going to go back to this. I'm going to hit 2, and then I don't need these zeros, so I'm just going to hit delete, delete. And then I need to make that EE. I need to pull and take that up another 3 to 6 since we're in megaohms. And there we go, 2.10, right? Scientific notation, or not scientific, engineering notation. 2 decimal places. And then again, I'll show you one more thing. I don't need to do this, but I'm just going to do it for your sake. if I hit second entry multiple times, I can actually just go summon past equations from a long time ago. It doesn't, it goes around, I would say, I don't know, offhand, I've never counted, like 10 times before it recycles to the last one that you did. But that can be useful at other points if you need to go back and do an equation again for whatever reason. So anyways, that part's over. So now what we're going to do, and I'm going to hit clear. Don't need all that. So now what we're going to touch on is using the inverse key. So here's a circuit where we've got 50 volts DC going through some resistance, and we don't know the current, but what we're given is conductance. G equals 4 microsiemens, S being big S being Siemens. Now, what we know is that G is the inverse of resistance. Well, if we know that, then we know we can get resistance. So, most of the time, what you might, if you're not familiar with a calculator like this, what you might end up doing is saying 1 divided by 4, and now you know, second EE, negative 6, right, for a micro. And that gives us this. That was kind of lengthy. I don't have to do that. It could be lengthier, right? But let me reduce the keystrokes here. I can delete. Let me get this where I want it to be. What I can do is use this button right here, this X to the -1. This is the same thing. This is the inverse button. And so all I have to do is hit that. And it pops up with this little exponent of -1. And I hit enter. Ta-da! So now we know that our resistance equals 250. You can see the E3 kiloohms. All right. So we just learned made use of the E button, the second EE. We used the inverse. I'm pretty sure I used delete and arrows in there. Now let's solve for I. So as a reminder, our DC voltage here is 50 volts. And let's say divided by, now Ohm's law, we've got voltage. Let's do Ohm's triangle here. Voltage, current, resistance. Voltage divided by resistance is current. Voltage divided by current is resistance. And current divided times resistance is voltage. So right now we're solving for I. So what we know is 50 divided by 250 kiloohms, right? I want to show your work. But what I can do is just 50 divided by, and I can hit second, and above the negative sign right here is the term ANS, which is answer. And I can hit second answer. It's just going to say answer, but it's referring back to what you just came up with in your last calculation. And so that gives me 200 microamps. Now, if you want to check it just to make sure that I'm not lying to you, let's do 250 EE3, and we get the same answer. So that was, again, that saved a lot of keystrokes. When you're taking a timed test, this is going to help you. All right, so last one. I use a lot of spare paper. That's all this extra stuff is. Now this is an example. Let's clear that. This is an example from the book that we use for DC and AC, the Boylsted book. This is figure 1530. What we're looking at here is an RL circuit. So I know that AC you haven't gotten there yet, but that's okay. Just maybe, pocket this away. But what you have done a little bit of is rectangular and polar form. And so I'm not doing the whole equation. What I just want to show you is how you can use rectangular and polar in your calculator very quickly to convert between the two. Now, if you have, kind of an older calculator, you might have to do some extra calculations that because your calculator may not offer you all the options that mine does. But in this particular case, we're not going to have to do these. Okay, so here's the rectangular form. You've got your real, your resistance, 3 ohms, and then your imaginary, your X sub L is 4 ohms. And so how you write that in rectangular is 3 ohms plus J, 4 ohms, right? So they gave us in the book, because they gave us the answer for polar. We've got 5 ohms, angle of 53.13 and degrees. So let me show you how you can arrive at that in the calculator. So I'm going to go, this is where you're going to use your second button again. Sorry about that. So you've got this blue button here that says apps, and above it you've got a yellow angle thing. And so I'm going to hit second angle. Now if I want to go to from rectangular to polar, I have to do this twice. One is rectangular to polar real, and the other is rectangular to polar angle. At least I think it's real, but it's fine. So here's what I'm going to do. I'm going to put in my rectangular form, 3 ohms, comma, 4. And that's all I'm going to do. And so that gave us the 5 ohms right there in polar form. And then I have to do that again. And I can just come in here and what I did was I hit second entry so that I could pull up these same values again. But now I'm just going to go back. I hit real quick second angle. I went back into that. And I'm going to do the other one, R polar angle. And so there my values are, because I already put them there. And that gave us 53.13 degrees. Now, if I wanted to reverse that, again, second angle. And I'm going to hit, this is your polar to rectangular X, polar to rectangular Y. And so now I'm going to put 5, comma, 53.13, and that gave us 3. So it's always going to give you your real first. I did second entry to pull up those values again. And then I went over this value because that's what I want to replace. And I hit second angle. And I'm just scrolling up. I already know where these are, so I'm kind of doing a shortcut here. Polar to rectangular Y. I'm going to hit it again. And that gave us 3.999. This is where you're going to rely on yourself to know to round up to 4. But that gave us 3 plus J4. And that's everything. I hope you enjoyed this calculator video. It should be really helpful for DC, AC, and everybody, okay? Thanks.